Welcome back to Learning with me, Ms. Killen, here at MPB. We are in our Unit 3, Inequalities. So let's go ahead and look at Lesson 4. It's working with compound inequalities. We're looking at REI.3. I can solve compound inequalities while understanding the difference between and, or. So let's remember how we said inequalities help compare the numbers and the variables, like x is greater than 6 or y is less than or equal to a -3. What we're saying is these are our bigger numbers, which is at the biggest part of my inequality symbol. That's where the bigger number is. So we need to make sure that we're remembering that. So we also need to see if we have limitations on where our solutions could possibly be. If you have a scenario where you can have an unlimited solution between two numbers, then you have this. You have A is less than or equal to X, which is less than or equal to B. There's an unlimited amount of numbers or different solutions between the letter A and the letter B, meaning numbers. Okay, when we have that, it's called a compound inequality. Okay, there is multiple solutions between these two unknowns. When two statements are joined by the word and, the compound inequalities solution lies between two numbers that are solved. So if I had -4 is less than x, which is less than or equal to 6, there are so many numbers between -4 and 6, and not just whole natural numbers. We're talking about decimals, we're talking about fractions. So there's so many. We have to make sure that we know those limitations. So it says, on a number line, we would graph this with the limitations of -4 and 6. So let's go ahead and look at that. So I'm going to put my 0 so I can see where both of them compare. I have -4 and -6. Now, what we're having to use is -4 is less than x, which is less than or equal to 6. So I have an open circle at -4, but I have a closed circle at -6. Now, where did we say that all of our possible solutions could be? Between them, right? It's between -4 and 6. So what I'm going to do is I'm going to graph between these two numbers, showing that all my possible solutions can be between those two numbers. All right, so let's look at some more. We still see the -4 cannot be part of the solution, but 6 can be included. On your inequalities table, you need to make sure that you add these, that with our less than or greater than, we have the parenthesis, and with our less than or equal to or our greater than or equal to, we have our bracket, which we have been using in this unit. So if I was going to write an interval notation, I would have put parentheses -4, 6 bracket. So we need to make sure that we're understanding when to use parentheses and when to use brackets. Good job. Let's try some and problems. That means it's going to be between the numbers. So if I am going to write from this graph, I have -2, and then I have a +7, and my x's are between. So how can I show the comparison? Well, it says that -2 is less than or equal to my unknowns, and my unknowns are less than 7. So that's how we're showing that inequality expression from that graph. Let's try number 2. So let's get a different color, because you know I'm all about the colors. I have 4 and I have 11, and I know that my unknowns are between them. So let's look at the comparisons. 4 is less than my unknown, and my unknowns are less than 11. So I can have anything between 4 and 11, but they cannot be 4 or 11. So you want to make sure that you're understanding the meaning of these symbols. Let's look at number 3. So I've got -3. I've got 2. It tells me that my unknowns are in the middle. Now, when I compare them, -3 is less than or equal to my unknowns, and my unknowns are less than 2. So we've got to remember what happens when I can be a part of the solution and when I cannot be a part of the solution. Let's look at number 4. So I have, let's get one more color. Let's do orange. So I have -4 and I have 0. It tells me that my unknowns are in the middle. So it says that -4 is less than or equal to x, and x is less than or equal to 0. So now I have it where my unknown or my solutions that I'm looking for can be a -4 and it can be a 0. Good job. So here we go. We have 2 notations to learn, and we've used these a little bit in our last 2 lessons, but I want us to really put down a definite about what this set notation is and about what this interval notation is. So on your notes page or wherever you're taking notes, let's go ahead and write an exact what these 2 are. So I'm going to go ahead and get this color. Now, when I have set notation, we said that it looked something like this. That means that all sets of x, so we have all sets of x, and this meant such that, and then it tells me what my x's can possibly be. So this is a grammatically correct inequality. We've heard that before, grammatically correct. We have all of my sets of x's such that, and then it tells you what your x's can or cannot be. So then our interval notation, this is the intervals where our possible answers can be. Now we said we can either have starting a parentheses, or I can start with a bracket, I can end with parentheses, or I can end with a bracket. Now, depending on my inequality symbols depends on what I use. So what were they? If I have an open circle, so we're going to put open circle, we have parentheses. If I have a closed circle, we have our brackets. And we also learned that if we use what concept? Infinity. So if I have either negative infinity or positive infinity, I'm still using those parentheses because it's a concept, not an exact amount. All right, so let's go ahead and look. Now let's go back through 1 through 4 and let's put those interval and set notations. So number 1, we said it can be the -2 and it goes to 7 but cannot be 7. So then it also says that x's such that -2 is less than our unknowns and our unknowns are less than 7. Number 2, I have 2 open circles. So I have parentheses 4, 11 parentheses. And we have all the x's such that 4 is less than the unknowns and the unknowns are less than 11. All right, number 3, I have an open I have an open circle and I have a closed circle. So I'm going to start with my bracket at -3 and I'm going to go to 2. So it starts with the bracket but it closes with a parenthesis. So then for my set notation, I have x's such that -3 is less than or equal to my unknowns, and my unknowns are less than 2. All right, let's try the last one. I have 2 closed circles. So I have a bracket at -4, and I also end with my bracket since they can equal both of them. So then I'm going to put x such that -4 is less than or equal to my unknowns, and my unknowns are less than or equal to 0. So that's how we're using our set notations and our interval notations, and it's telling much the same information just in multiple ways. Good job. All right, when two statements are joined by the word or, the compound equality solutions cannot lie between the two numbers that are the limitations. X is less than or equal to -4 or 6 is less than my x. On a number line, we would graph this with the limitations being starting and stopping points. With the or, we now must factor in our infinity, negative and positive infinity. So let's go ahead and put this. I'm going to go ahead and put my 0. I have my -4 and I have my 6. Now, it says that my unknowns are less or equal to. So I know that's closed circle. And it also says that my unknowns are smaller than my unknowns. Excuse me, my 6 is smaller than my unknowns. So I have an open circle there. So we're going to graph. It says right here that my unknowns are smaller or equal to. So I'm graphing here. It also says that my unknowns are bigger than 6. So I'm graphing here. What could we say my limitations are? What could we say my boundaries are? My unknowns cannot be between -4 and 6. They just can't be there. So then they can either be -4 and smaller, or they can be 6, not necessarily the number 6, but bigger than 6. Okay, so it's either or. It cannot be both. All right, so then it says we also need to think about infinity and negative infinity. So let's go ahead and write those interval notations to work with those negative and positive infinities. So here we go. I am going to have parentheses, negative infinity, comma, -4, bracket. And then here I'm going to have parentheses 6, comma, positive infinity. Now, how can I put that it's both of those with my limitations and where my unknowns can be? I just can't put them like that because I'm going to think it's two different inequalities. I could put the word or, but then I could also use our symbol. We have a symbol which looks just like that. All right, so when I wrote these, I could put negative infinity, -4. So again, I have a complete algebraic expression that is grammatically correct, that gives us information about all of my possible unknowns with my interval notation. Good. Let's go to the next thing. Let's try some or problems. All right, so what we're going to do, 1 through 2, is we're going to write those expressions. 3 through 4, we're going to graph them. So let's go ahead and look. So for number 1, I am looking at an open circle, and then all of my unknowns are smaller. So I would put, let's see, my unknowns are less than 3, or my 10 is less than or equal to my unknowns. So then if I wrote that in interval notation, it's going to look like this. Negative infinity, comma 3, parentheses, or, bracket 10, comma, positive infinity, parentheses. So that tells me the exact same thing. I have it written as an inequality expression, or I have it written as my interval notation. Let's look at number 2. All right, so I have 2 closed circles. So I'm starting over here at my unknowns, and they are less than or equal to 0, or I start with my 1, and it is less than or equal than my unknowns. So let's write that in interval notation. So since I start this out with a negative infinity, and I go to 0, and it can equal, or I start with 1 where it can equal, and I go to positive infinity. Good job. So now 3 and 4 has given us those expressions. I need to take from the expression and put it on the graph. So let's see what that looks like. I'll get a different color. So my unknowns are less than or equal to -2. So that is a closed circle, and they are smaller. So I am graphing to the left, or 3 is less than my unknown. So that's an open circle, and I'm graphing to the right. Let's look at number 4. X is less than or equal to 13, or 15 is less than or equal to X. So let's see what that looks like. So my unknowns are smaller than 13. So I have an open circle. And 15 is less than or equal to X, so I have a closed circle. So they're smaller going to the left, or they're bigger going to the right. Look and see how your arrows are going, making sure that it's telling you where all the possible unknowns could be. That's the key for these, because you want to make sure that what's being said in the expression is what you've put on your graph, or what's on the graph is what you put in your expression. Good job. When you are given the inequality to solve, you follow all the rules and properties, okay? You follow all operation rules to get the variable by itself. Now, whatever you do to one part of the inequality, you're going to do to all of the parts. All right, so let's look at this. My X is in the middle, of course, but I have other numbers there with my X. So just like we've been doing ever since we've started, we want to get that X by itself. So let me show you how we do that. So the first thing I'm going to do is I'm going to have to subtract that 1. Let's get a different color so it shows up just a little better. So I'm going to subtract that 1. Now, whatever I do to one part of this inequality, I must do it to all parts of the inequality. So I have -4 less than 2x less than or equal to 6. Still don't have that variable by itself, so now I'm going to have to divide. So I'm going to divide by 2 to all of my parts of this inequality. So I have -2 less than my variable, which is less than or equal to a +3. So let's go ahead and graph that, and let's see what that looks like on a graph. So here we go. So I've got my -2, I've got my 0, and I've got my +3. I have an open circle at -2. I have a closed circle at -3. Now, compared to -2, my unknowns are bigger. So I'm going to the right. And compared to my 3, my unknowns are equal or smaller, so I'm going to the left. So we could almost say that this is an and problem, okay? It's an and problem. And we can also say that it is graphed and notations written the same as before. So let's go ahead and write both of those notations. So since it's an open circle, I have a parentheses at -2, 3. Since it's a closed circle, I have my bracket. Then as my set notation, I have x such that -2 is less than my x, and my x is less than or equal to my 3. So those are my two notations for this problem. All right, so we graphed it, we wrote our notations, and we worked our inequality. Remembering, everything you do to one part of the inequality, you must do to all parts of the inequality. All right, so let's see what we have next. What about this problem? 4x minus 5 is greater than or equal to 3, and 2x plus 1 is less than 9. So let's go ahead and work these and see what we get, and then we can go to the graph. So here we go. All right, so the first thing I'm going to do is get my variable by itself. So I'm going to add 5 to both sides. So I have 4x is greater than or equal to 8. I'm going to divide by a +4. So x is greater than or equal to 2. And let's work this one. I'm going to subtract 1 on both sides. So 2x is less than 8. I'm going to divide. So x is less than 4. Let's put this and see what we have. So at 2, I have a closed circle. And at 4, I have an open circle. Now it says that all of my variables are bigger or equal to 2, so I'm graphing to the right. And it also says that all of my variables are less than 4, so I am graphing to the left. So I have an and problem. They're between 2 and 4. So let's go ahead and write those notations. So here we go. So since I start with the closed symbol, I have a bracket at 2, comma 4, parentheses. So then I would also have x such that, what? Negative 2 is less than or equal to my variables, and my variables are less than 4. Now, you're looking at this and going, Miss Killen, that's not exactly what you wrote, but isn't it? Remember, we're looking at meanings, not necessarily points. I'm saying that my 2 is smaller than my x, or my x is larger or equal to my 2. Does that not what this says? Negative 2 is less than or equal to x, or x is greater than or equal to negative 2? Says that. Also, it says that my variables are smaller than 4. My variables are smaller than 4. So I'm saying the same thing, I'm just writing them with the exact same type of inequalities. When you write this set notation, unless there's no way, form, or possibility, you always try and use the same type of inequalities. All right, so let's go to the next one. It says, does it work with OR problems? All right, work each part of the compound inequality separately. You will still graph and have the same notation. So let's go ahead and work this. So I'm getting my x's by themselves. So I'm going to have my variables on the left and I'm going to have my numbers on the right. So I'm adding 3 to both sides. So x is less than negative 2, or I'm going to subtract on both sides. X is greater than positive 5. Okay, so let's go ahead and graph these and see what this one looks like. All right, so I'm going to have negative 2, 0, and 5. I have open circles at both. Now it says that my variables, my unknowns, are smaller than negative 2. And it says that my unknowns or my variables are bigger than 5. So does your graph look like my graph? Okay, so now let's put our notations. I'm going to do set notation first. So my x's such that my x's are less than negative 2, or 5 is less than my x. Notice how I used the same type of inequality symbol. That's what I was talking about. Even though we're doing the and or the ors, I try to use the same inequality symbols. I can say the same thing, just depending on where I place the numbers and the variables. All right, so let's go ahead and put interval notation. So my interval notation would obviously start with my negative infinity and go to 2, parentheses, because it can't equal, or it also means union later in, but we're going to keep it with or, parentheses, 5, and go to positive infinity. So I've graphed it, I've worked it, I have put both of my notations, and they are saying the exact same thing. All right, here we go. Notice my negative and my positive infinities will always go with parentheses because it can't be an exact number. It can never equal infinity. That's just a concept. Good job. Okay, what about this problem? Miss Killen, you're making a specific problem, so this may be a little funny business. I don't know, let's work it. So here we go. 4x is greater than 8, or x minus 6 is less than 0. So let's go ahead and get our variables by itself. I'm going to divide by a positive 4, so x is greater than 2, or I'm going to add 6 to both sides, and x is less than 6. Let's go ahead and graph this and see what this does. So I've got 0, I've got 2, and I've got 6. I have open circles at both of them. Now it tells me that x is larger than 2. We're graphing. It also tells me that x is smaller than 6. We're graphing. Okay, so what does that mean? I have open circles, so it can't be them, but it's telling me that all of my possible x's can be bigger than 2, or all of my possible x's can be smaller than 6, but I have limitations. Let me show you what these limitations are. All right, so this is going to be one of those special cases. You know, in math, you always have to have the special cases. All right, so we're going to say that this could be all real numbers. Because in this, for instance, it can equal 2. In this, for instance, it can be 6. So x's such that my x's equal all real numbers. And then I would put negative infinity to positive infinity. Because depending on which part of the inequality that you're looking at, depends on what it can or cannot be. So in one part or the other, it can be with the other part saying it can't. So you have to make sure that you're watching for these special cases. We're going to have special cases throughout this Algebra 1 course, so you've got to make sure that you're paying attention to them. All right? So let's look. There is a special case. Every number is either greater than 2 or it's less than 6. So full solution is all real numbers because every number satisfies at least one part of this. And that's just what it says, at least one part. Good job. All right. It also tells us you can always have a special case within math. Almost all of our concepts, it doesn't matter if it's algebra, it doesn't matter if it's geometry, algebra 2, you're always going to have those special cases. So I don't want you to go, wait a minute, that goes against everything you've told us. No, there's always going to be special cases. All right. Time for you to master. I want you to solve each inequality, graph, write set notation, and write interval notation. All right, so you or you and your table partner, go ahead and work this 1 through 4, see what you get, and then come back and we'll compare. Okay, I'm going to work 1 through 4. I want you to compare what you have to what I get, and let's see what we get. Here we go. So the first one, it says negative 6 is less than 2x minus 4, which is less than or equal to negative 8. So I've got to get my variables by themselves. So I'm going to add 4 to every part of my inequality. So I have negative 2, which is less than 2x, which is less than or equal to 8, 9, 10, 11, 12. Then I'm going to divide everything by that positive 2. So I get negative 1 less than x, which is less than or equal to 6. So let's go ahead and graph that. So I have negative 1, 0, 6. I have an open circle at negative 1. I have a closed circle at 6. Now it's saying that negative 1 is smaller than all my variables. So I'm going to graph here. And it's also saying that all my variables are smaller and equal to negative 6. So I'm going to graph here. All right, so then I'm going to do my interval notation first. So since it's an open circle, I have parentheses, negative 1, comma, 6, bracket. Also x such that negative 1 is less than x and x is less than or equal to a positive 6. Good job. Let's do number 2. Let me get a different color. All right, so 3x minus 5 is less than negative 2 or x plus 4 is less than 10. So let's get our x's by themselves. I'm going to add 5 to both sides. So 3x is less than 3. I am going to divide by 3. And x is less than 1, or subtract 4, x is greater than 6. Now, I know Ms. Killen is making a big deal about that word or, but that is really, really important that we see it can be either or, okay? So let's go ahead and see what else we have with this one. So I'm going to graph it. I have 0, 1, 6. X is smaller than 1, so I have an open circle, and I'm graphing to the left. Or X is bigger than 6, so I have an open circle, and I'm graphing to the right. I would start my interval notation with negative infinity, comma 1, parentheses, or parentheses 6, positive infinity. We would also write that as X such that X's are less than 1, or 6 is less than X. Now, it's the same thing. I'm just writing it with the same exact inequality. All right, so let's do number 3. Let me get a different color. Do purple. All right, still getting X by itself. So I am adding 3 to both sides. So 4X is less than or equal to 8. I'm dividing by the positive 4, so X is less than or equal to 2. And subtracting 2 on both sides, X is greater than negative 2. Let's graph it. So I've got negative 2, I've got 0, I've got positive 2. It says that X's are equal to or smaller than my 2, and they're also greater than my negative 2, so it's going to be graphed like this. My interval notation is going to be negative 2, comma positive 2, bracket, and then X such that negative 2 is less than my variable or my unknowns, and my unknowns are less than or equal than my positive 2. All right, last one. Let's do orange. Well, it's already there, so let's go ahead and graph it. I have 0, I have 1, and I have 4. X's are smaller than or equal to 4, and I have a closed circle. And then I have X's are bigger than 1, so I have an open circle. So I am what? I'm graphing these. Now, it says that this one graphs all the way, no problem. But this one is graphing this way. So this would be another special case that we can maybe look at. So I could say that I have negative infinity to 1, or I could have 1 to positive infinity. All right, so we may look at it like this. X such that X is less than 1, or 1 is less than or equal to X. So this would be another special case. Now, when I'm looking at these, sometimes you may see these where you have the parenthesis, because I do have this limitation. And sometimes you will have this where it's just the less than 1, because you do have these limitations. So I want you to make sure that you're looking at these. Even though this is what we've seen, I do have these limitations. All right, so that is another special case we have to be careful with. All right, so here's another one. Okay, number 5, 6x plus 4 is less than or equal to 9x minus 1, which is less than or equal to 4. All right, so what I need to do is I need to get all of my numbers away from the middle. So how I'm going to do this is I'm going to get my numbers away from the middle, get all of my variables into the middle, break apart the two inequalities that we have, and answer what is, and then my variable, and then what is. So let me get a color, and let's work this. First, I'm going to use these two, and then I'm going to use these two. So I have 6x plus 4, which is less than or equal to 9x minus 1. And you may be sitting there going, Miss Killen, earlier in the lesson, we had 3 parts. We did, but we did not have variables in all 3 parts. So that's why I'm doing this a little different. This one is another special case. So let's look. So I have 6x plus 4, which is less than or equal to 9x minus 1. So let's get all my variables on the left side and my numbers on the right. Or we can put our numbers on the left side and our variables on the right. Let's do it that way. So I have 6x, I'm subtracting on both sides. So I have 4 less than or equal to 3x minus 1. So I'm going to add 1 to both sides. So 5 less than or equal to 3x. I'm going to divide by 3. So 5/3 is less than or equal to my variable. So now let's do the next one. I'm going to do it in green so we can see a little different. So I have 9x minus 1, which is less than or equal to 4x plus 7. Getting this by itself, I'm going to put my variables on the left, numbers on the right. So I'm going to subtract 4x on both sides. So I have 5x minus 1 less than or equal to 7. I'm adding 1 to both sides. 5x less than or equal to 8. Divide x less than or equal to 8 over 5. So let's go ahead and put those together. So I have 5/3, which is less than or equal to x, which is less than or equal to 8 over 5. So I've got my inequality. So let's go ahead and graph that. Let's see what that looks like. So I've got 5 over 3, and I have 8 over 5. Close circles for both. And there you go. So if I wrote those notations, I would have a bracket, 5/3, 8/5, bracket. And then I would also have x such that 5/3 is less than or equal to my variables, which is less than or equal to 8/5. So this is another special case where I'm going to have to separate them, 2 here and 2 here, and then put them together at the end, because there's no way that I could have kept them as the same expression and been able to get all my variables in the middle and my numbers on the inside, or the outsides is what I've done. So always making sure that that variable goes in the middle, and we use our inequalities for the same. We had our less than symbols equal to, less than symbol equal to. So we make sure that we have these numbers that can be smaller or can be bigger, and we have to show those on our graph. Good job. Some things that I don't want us to forget are what compound inequalities are. Okay, we have multiple numbers that we are comparing to our unknowns, how we graph the and also the or inequalities, what those look like, how our arrows look when we're graphing those different ones, how we write set and interval notation. One of them has our parentheses and our brackets. Another one is with that x such that. And you always get your variable in the middle of compound inequalities because you are comparing that variable to 2 types of numbers. I'm so glad that you came to learn with me here at MPB today. We are in Unit 3. We're almost at the end, so I want you to have a great day.